Namaskar, aspirants, and welcome. Today, we're going to delve into a really fascinating topic for your GS Paper 3. It's a deep mystery right at the heart of particle physics, something known as the Flavour puzzle.
Exactly. And, this isn't just some abstract global quest. It's one where India plays a really significant role, and that makes it directly relevant for your syllabus.
All right, so here's how we're going to break this down for you. First, we'll look at the puzzle itself. Then, explore what these three generations and nature are. After that, we'll connect it to some deeper cosmic mysteries, discuss why it's so relevant for your UPSC exam, and finally, look at how scientists are trying to solve it.
Okay, let's start with the standard model of particle physics. Now, this is our most successful theory ever about fundamental particles and forces, and yet, it's incomplete. You see, it gives us the how, but not the why. And for a mains answer, that's a crucial distinction. The theory is packed with what scientists call free parameters. Think of it this way. It's like a recipe that tells you to add exactly 1 gram of salt, but it has no explanation for why it has to be 1 gram. Scientists have to go out, measure these values in experiments, and then just plug them into the equations. The theory itself can't predict them.
So, where does the standard model start to show its cracks? Well, that brings us right to the heart of the puzzle, the bizarre fact that fundamental particles seem to come in triplicate. They appear in what we call 3 generations. And the term they use for this is flavor. Now, don't let the name confuse you. It has nothing to do with taste. It's simply the term physicists use to talk about the different types of particles. You can just think of it like 3 different versions of the same basic blueprint.
Now, just take a look at this table. It lays out the 3 families perfectly. The first generation at the top, that's everything. It makes up all the ordinary matter around us. You, me, the earth, the stars. But then you have these other 2 generations, which are basically just heavier, unstable copies. It's like nature built our entire world with 1 set of Lego bricks, but then created 2 more identical but much, much heavier sets that just crumble almost instantly. The big question is, why?
And that really captures the surprise perfectly. When the muon was discovered, which is basically a heavy electron, about 200 times heavier, it was completely unexpected. The physicist I. Rabi famously asked this very question: why is there a second, and for that matter, a third copy of everything?
Okay, and the puzzle just keeps getting deeper. It gets even stranger when we look at 2 things: the bizarre differences in their masses and a possible link to one of the biggest questions in all of cosmology. The masses are just all over the place. There's no clear pattern at all. It's as if you had 3 siblings where one weighed as much as an ant, the next as much as a person, and the third as much as an elephant, with absolutely no explanation for these wild differences. The standard model can't predict these values. Scientists just have to measure them and plug them in. This is what's known as the mass hierarchy problem.
And this leads us to something incredibly important and very relevant for the mains exam, the matter-antimatter asymmetry. You see, according to our theories, the Big Bang should have created equal amounts of matter and antimatter. If that had happened, they would have just annihilated each other, leaving behind a universe with nothing in it.
The flavor puzzle is directly tied to this. There are these tiny, tiny differences in how particle flavors and their antimatter twins behave. It's a phenomenon called CP violation. Imagine a particle and its antiparticle are perfect mirror images, except one of them has a tiny extra freckle. That tiny difference, when you multiply it over billions and billions of particles, could be the reason why matter won out in the end. The problem is, the freckle predicted by the standard model is just too small. It's not enough to explain the universe we see. So you see, solving the flavor puzzle might actually explain why we exist at all.
All right, so let's bring this all back home. How can you actually use this information in the exam? Let's get very specific about it. Aspirants, you really should be prepared for direct questions like these. And notice, they don't just test your knowledge. They're testing your analytical ability to connect different concepts, from the limitations of a scientific model to the importance of international collaboration and even the very nature of scientific progress itself. So, as you make your notes, make sure these keywords are right there at the top. You should be able, for example, to clearly explain how the free parameters of the standard model lead directly to the mass hierarchy problem. Using this kind of precise terminology is absolutely key to scoring well in GS Paper 3. So, where do we go from here? How are scientists, including many from top Indian institutions like the IISC, actually trying to crack this puzzle?
Well, the search is really a multi-pronged approach. Scientists aren't just looking for answers within the existing standard model. They're exploring some pretty radical new ideas that go way beyond it.
And the potential solutions are just profound. We're talking about entirely new forces of nature, or theories that unify all the existing forces, or even the possibility of extra dimensions of space. It just goes to show that our understanding of the universe is far from complete, and that science is this continuous process of inquiry. Answering this one why could literally rewrite our entire understanding of physics.
So we'll leave you with this thought, which is a fantastic point to consider for a potential interview question. As a future policymaker, how do you think India should balance this kind of fundamental blue sky research against more immediate mission-oriented needs? Remember, the quest to solve puzzles like this one might seem abstract, but this is what drives technology, what fosters international collaboration, and what inspires the next generation of scientists. There is immense value in seeking knowledge simply for its own sake. Thank you for joining us, and all the best with your preparation.